Okay, so let's move on to problem 2, where we've got the International Space Station orbiting the Earth at a, so here's the Earth, and here's the space station, which we'll draw as a box, and it orbits the Earth at a particular height, or an altitude above the surface, which is 380 kilometers. So we want to know what the speed of the International Space Station is. Okay, so it's a circular orbit with a radius given by little r here, and little r is going to be the radius of the Earth plus the altitude of the space station, the space station, which I'm going to represent with an h there. So we know the radius of the Earth from the previous problem. It's 6,371 kilometers plus the altitude of the station, which is 380 kilometers. So the radius of the space station's orbit then is going to be 6,751 kilometers. Okay, great. Now we want to know if the space station is going around a circle like this, and it's pulled into the circle by gravity, of course. What is the there's the force of gravity. So we want to find out what its speed is. So we have an object here moving in a circle, which means it's moving at a uniform speed. Circular orbits always move at uniform speeds. So this is a classic circular motion problem, and the circular motion problem, the fundamental equation for circular motion problems, I've always said, is A equals A. Okay, one of your A's comes from the kinematics of circular motion, and one of your A's comes from some kind of force analysis. So in this case, what will be easiest for us, we want to find the speed of the station, right, which is v. So the easiest thing to do is use v squared over r as our left-hand A. So this is our centripetal motion, our uniform circular motion A on this side. And on the other side, we're going to use, tell you what, let's go with m times that equals F. Okay, so that's the net force in the thing, and really the only force on it is gravity. Okay, so what I want to do now is go m v squared over r. This little m here is the mass of the station, right? Is going to equal big G times mass of the Earth times mass of the station over the radius of the station's orbit squared. And now you can see pretty easily, I think, that dark green. I like dark green. That these r's here cancel, and the little m's cancel. And so what you're going to get, is it really this easy? Oh my gosh, yes it is. You're going to get v squared, and v is what we're trying to find. It's the speed of the station, of the station in orbit. So it's equal to capital G times me over r. Okay, so all you have to do now is take the GME that we got from the previous problem and the r we have from this problem. Be careful of your units. Remember, this is in kilometers, and GME is in meters cubed per second squared. Take the the quotient of the two and square root it. And my recollection, I hope I'm right about this, is that the speed of the station is 7,680 meters per second, rounded off to the nearest 10 meters per second. I suppose I could check that. So let's just say I'll check that, and if it's wrong, I'll post a little addendum, but I'm pretty sure it's right. So that's problem 2.